Yeah, thanks for having me. I hope you had a great lunch, and I'm not tired after my talk, for my talk now, because it usually happens after having lunch. Yeah, so today I would like to talk about lean AI. I think maybe some of you haven't heard this term. So today I will explain what it means and actually how you can use lean startup approaches in machine learning. And I will also show a use case that we did at one of my former companies, and actually how you can use it basically to implement basically deep learning model in production. All right. Before going more in details, so let me introduce myself. So I'm Tran. I'm from Berlin. I'm currently the CTO of Pretrained. Pretrained, basically, it's a startup that I co-founded together with with Dr. Schwenke 2 years ago, and we are basically building a no-code spreadsheet platform. I will also show in a minute what this is about, since we're also on a developer conference, and basically, yeah, it might be worth if you could also try it, because we just released our alpha version, and we also will open source this platform soon. Before that, I used to work for Axel Springer. Anyone heard of Axel Springer in Sweden? Okay, one person. Yeah, I think it's not really well known here in Sweden, but it's actually one of the biggest media company in Europe. So they own like Business Insider and Politico. So those are the media outlets that you might know. And before that, I used to work for Diallo, which is a price comparison website. And this is also a use case which I did at this company. And long time ago, I used to work for the company called Pivotal. So if you are into Spring Boot, Spring project, Spring framework, then Pivotal, then probably you're aware of Pivotal. Yeah, let me just shortly show the product that we're building. I mean, since we're on a developer conference, I just want to show this as well. And we just recently released it as well. So it's a basically cloud-based spreadsheet where you probably know Excel and Google Sheets. But what we built basically is a more powerful spreadsheet, which can also power external functions. Yeah, if you, for example, if you're interested, so you can actually have a look, like log in and register yourself. Here in this example, I just powered basically, I wrote my own function, which is called price of currency, where you can take basically a source and a target currency. We have a CLI, so basically if you use npm install, you get our CLI, and then you can also create your external functions by yourself. So just have a look at our documentation, which is at docs price.ai, and if you're interested, so yeah, since you're also developers, would be also interested to get to know your experience as well and how well it works. But nevertheless, this is not the main topic for today. If you're also interested, I do a lot of open source as well, and also the projects that I did, we always put it on for free in open source. So one of the topics I will also talk today, so which is the image quality assessment, but we also work on image super resolution, but also on text-to-speech topics. So if you're interested, you can actually also have a look at those projects. Other than that, as I said, I contribute to open source as well a lot, but also write blog articles on Medium and so on. Okay, why do I do this talk? Or why this talk, right? Well, I mean, I'm not quite sure in Sweden, but definitely in Germany, there's a statement actually that almost 90% of the projects fail. Not quite sure if it's in Sweden. Well, do data science projects fail here or succeed? So basically, it's different than here. But basically, in many companies, like over the couple of last years, they invested a lot of money into machine learning, data science, tons of money, and basically, with the projects that I basically seen, also with other companies, they literally failed, right? So because they invested into the wrong things, you know, they invested into infrastructure, people, but not into the right things. Well, there is a solution to that. So this is what I call lean AI. So let's go in terms of the lean. You probably heard of a lean startup, right? So lean startup approaches. What is actually lean? So the core idea about lean is that you're creating like the most value for a customer with minimal cost, right? So what do I mean with this? So this methodology is called lean startup, as I said. And one of the two core components of the lean startup is basically build, measure, learn feedback, and also MVP. Let's go deeper into all of this stuff. So what does build, measure, learn means? So build, measure, learn means is you're building something, then you basically measure the impact of it, and then you learn. It's pretty simple, right? So nothing complicated, but it is simple, but people do it really, really wrong. What is MVP? So MVP, Eric Ries is one of my former colleagues at Pivotal. He says that a minimal viable product is essentially a version of a new product which allows the team to collect the maximum amount and validate the learning about customers with the least effort. I mean, if you're product people and if you work for a tech company and you have product people, you probably should know by heart, right? But how do you actually use it for machine learning, right? Because, and I will also show how they are really related to this build, measure, learn, right, and MVP concepts. Yeah, I mean, just to give an example, what is not an MVP and what is an MVP? So not MVP is basically if you know probably this pyramid, right, with functional requirements, reliable, usable, and also emotional design. So not MVP is if you have the full pyramid. Also not MVP is if you just build a backend, right, without any UI. So basically you need a slice of the MVP. Another example, so you're new in Berlin. So the problem, you need a roof over your head. And the question is, what is the minimum solution to solve your problem? Anyone been to Berlin or anyone lived in Berlin before? Okay, so probably you know that a lot of people move to Berlin these days. So it's really hard to find a place. What you probably should not do is, you move to Berlin, you spend a lot of money, you buy, some land and then hire an architect and then plan everything. Well, what is MVP is about? Well, I mean, it's not really, reality, but you could go to Berlin, get a tent, right? Live somewhere. It's very hard to find a place in Berlin. So these days. Like, if I would say, ironically, a tent is basically an Airbnb, and then they stay in this Airbnb, and then over the time, they find, other Airbnbs, right, in Berlin, and then over the time, you basically can find your perfect spot. This is, I mean, simple terms, MVP. All right, so let's go to the term AI, and also demystify a little bit this term AI. So what is AI? So it's, according to Merriam-Webster, it's a capability of a machine to imitate intelligent human behavior. Well, probably you all know this tweet from Matt Valesio. So he says that the difference between machine learning and AI, if it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI. Right? So this is a PowerPoint slide, so it's AI. But obviously, what we do as a practitioners is actually obviously machine learning. So why lean AI? So why is this actually really important? Usually, if you work for companies, right? You usually work for a software company, and they have a product, right? And usually, machine learning is a feature, right? So if you think about machine learning isolated, right? There's many or only a few examples where actually this really works. Most of the time, basically machine learning really shines in the product. And this is, for example, example of one of my companies that I work for, which is Diallo. It's a price comparison website, as I said. What happens is usually you have basically UX, UI, who work basically on the interface, right? Then you have basically backend engineers who basically power the infrastructure, but also the backend to it. And then you usually have data scientists, data engineers, right, who basically also powers the backend engineer to do something more smart, so we call smart features. If we look at this kind of Venn diagram, so usually you have many, many roles involved in this, right? So if you work in a company where machine learning is isolated, well, this is totally wrong, right? Usually, machine learning should be integrated into feature teams. So it should be part of product management, it should be part of the user experience, and also developers as well. Let's look back into machine learning product lifecycle and how does it actually match to build, measure, learn. So in a typical machine learning lifecycle, what you do is you get a problem. So the problem might be, hey, I want to have a recommendation engine, or I want to, have a text-to-speech model. You define the problem. Once you have the problem, you do a data review. You basically check for missing values. You see that if there are some problems with the data, and then you basically design a bit the API, like where should it be deployed. Then you do some feature engineering, because most of the time when you take in the raw data in machine learning, it's not really enough. So you actually need to transform the data so that the model understands it better. And then you model the data, you evaluate the model, and then you take it in production, right? So you operationalize the model. Once it is out in the wild, what you need to do is you need to get user feedback, because at the end of the day, as I said, we don't really do AI, right? We do machine learning, which is based on data, which means data can be corrupt. In production, you have data drift, right? Which means that your model, whatever you produce in a lab environment will be completely different, right? That's why you need user feedback. If you look at the build, measure, learn concept again, right? So we can map it, right? So you have to build your model very fast. You have to measure your model, and then you have to learn it very fast, right? So what I'm saying here is that you can actually use product concepts into machine learning, because usually when you think about this product lifecycle, or you've seen it in other teams, what usually happens is that this whole lifecycle takes very, very long in many teams, right? So they don't really follow this iterative approach, but usually what they do is you have a problem, you review your data, and then I've seen research teams spending, 6 months, 8 months, 12 months, a year, just basically improving a performance metrics, and they never release it, right? So this is like a very problematic thing for machine learning teams. As I said, so the whole thing, if you do it well, it's about reducing risk, because we want to build something that at the end someone will use. All right, let's give an example, because people love examples and how we applied it. Because, the concept itself is very simple, but how to use it, it's actually more and more challenging. This is an example that I did at my old company at Diallo, which is called image aesthetic. So, which is a very, very hard problem for us. All right, so if you think about Airbnb or TripAdvisor, right? Whenever you basically book for an hotel, right? What are the most important criteria that you could think of, right? So I would say it is obviously the photos, right? If you, for example, travel to Bali, right? Look for a room, you probably would like to look at the pictures, right? One other aspect is also obviously the price, because price is also very important. But I would say that photos is really, really important factor. The issue now is, so this is a listing from Diallo, which has also like a hotel price comparison service, and they have like 300 million images, so it's quite a lot. I'm not quite sure if you can see this. So this is like when you go to Diallo and you look at this listing and you search for Berlin, this is one of the listings that you would get, right? So obviously, this is not really nice, right, as a first image. Can we agree or not? Yeah. Okay, it depends what you're looking for. Maybe in Sweden, because tonight we also go to sauna, right? So maybe it's nice, but usually this is not the best experience that you would get. And I would also say that these days, so I would call, so at least my generation, a bit the Tinder generation, right? So you basically swipe right and left and so on. But basically, we have a very short time to spend looking at one image, right? So the user experience needs to be really, really right in the beginning and also very, very fast. Another thing that you know when you go to Airbnb or other services, you don't only look at the first image, right? So you also go into a gallery. And when you go into this gallery here, you can see that there's a lot of images displayed, at different orders. So this is order 1, order 2, order 3, order 4, order 5, and then up to order 13. So let me show you a bit of perspective. So if you look at this gallery, you have basically a bedroom which is at position 1, and then you have another bedroom which is at position 19, right? What do you think looks better, position 1 or position 19? Yeah, I would also say that 19 looks better, but the problem is when a user goes in, he won't see position 19 first, right? He will see position 1. So he actually gets a very bad impression of position 1. So another example, like reception, right? So this is position 3, and this is position 17. So what do you actually prefer? 3 or 17? 17, yeah. I mean, at the end of the day, it's perspective. So I think I gave this talk in India, and they thought 3 is better. So as you can see, one thing already is aesthetic is about a lot about subjectivity. But for me also, 17 looks much better. So we can all agree that actually beautiful images should appear earlier in the gallery. The second thing that you can observe, if you look at this gallery, I give you 30 seconds. Can you maybe tell me what is so special about this gallery? Red towels, okay. Oh, what? No picture of canteen. So what is so special about this gallery here? So if you would look at this gallery, what is the similarity in this gallery? Yeah, I heard beds, right? So there's a lot of bedrooms, right? So basically, 80% of this gallery is about bedrooms. Obviously, this is not good because when you look into like a gallery or like you look into basically a product, right? In this case, it's a hotel room. You want to get different areas depicted. So someone said there's no canteen, there's no there's reception, right? But there's no bathroom, there's no kitchen or anything else, or maybe also the gym, right? So you want to ensure that different areas get depicted at the same time. So this would be the ideal case, so that you basically have bedrooms, bathrooms, restaurants, facades, fitness studio, and kitchen. All right, so the problem is pretty simple. So it's a two-part problem. First of all, what we call machine learning is basically tagging the image with the hotel property. It's called image classification. And the second thing is basically predicting aesthetic quality. I'm not going to go deep into the first problem. We actually solve both problems, but the first problem is in deep learning terms or machine learning terms pretty simple, so and also not very interesting. But the second problem is very interesting, right? It's about predicting aesthetic. Aesthetic is something I always wanted myself. How can you actually teach a computer, right, to understand what beauty means, right, for yourself? So we will go deeper into that topic. And obviously, this talk is about deep learning. I mean, it's in the description, and deep learning is the hottest thing, so we also use it. Okay, so how should we not solve the problem, right? So obviously, your business comes to you and tell you, hey, we have 300 million images, and all these small and medium business owners send, these images to us, but they are so messy, right? Because we want to give them a good user experience. Because just imagine if you, as a small and medium hotel owner, give Diallo the data and no one clicks on that, right? You don't really make revenue, which is bad for the small and medium business, but also for Diallo itself. Then the business comes to you and tell you, hey, we want to rank these images so that the first image looks much nicer compared basically to the other images. What you should not do is, okay, wow, let's hire a bunch of PhDs, from Stanford and whatsoever. Then, give them some brand new MacBooks M1 machines, and then buy, some GPUs for 20,000, 30,000 euros, right? And then put them in a lab environment, and then, let them come back after 6 months, and then show them the results, right? So this is something that you should not do at all. I've seen this in many companies where basically they hired a machine learning team or data scientist or whatever they call it, because sometimes companies that don't know the difference between all of these roles. And then they bought a lot of infrastructure, right? They spend a lot of money in that, and then they're just like, okay, please solve the problem. This is a metric, and whenever you're done, come out. This is what you should not do. So how did we solve it, or what was the success to the projects that we did? And I just want to show you how we did it, and also how basically Lean AI helped us to solve this problem. So what we did is basically, obviously, there in machine learning is not a young field, right? So machine learning is already 60, 70 years old. There's so many things that researchers have been doing already, but then there was some people, that's what's called the AI winter, because we didn't have enough computing power, right? And also the data was not enough. But over the few years, many people have solved problem already. Luckily, there was already a team at Google that basically predicted already image quality assessment, so basically aesthetic on some data sets. So, obviously use what you have already, so don't reinvent the wheel. If a problem is already solved in some way, right, or in a different way, maybe this kind of problem is solved differently for another problem, you could reuse it. So what we did is we basically followed this Google paper, which is called NEMA Neural Image Assessment, which is actually uses a lot of ideas from another paper from Harvard, how you can actually use Earth mover distance to basically fit a distribution function. What this model basically did is basically it predicted two models. So one is called an aesthetic model, which gives us back aesthetic score. And the second thing is a second model, which is called a technical model, which gives us a technical image quality ranking back. So what is the first model? The first model is very subjective. I'm going to talk about this soon. And the second thing is less subjective. It's pretty objective, right? So if you, for example, take a photo from with your iPhone, and if you take it very fast, what happens? Yeah, blur. So blur, so you get blurriness, you get distortion. So this is something that is very objective, because you can actually measure this kind of things. You can also measure colors and quality, right? So this is one of the things that is less subjective. All right, so what did we do exactly? So we basically use a pre-trained convolutional neural network. Everyone knows about the term convolutional neural networks? Yeah, that's pretty cool. And then we trained that, and then we basically replace the top layers, and then basically train it on our existing problems. Then another thing that we also did very, very fast is setting up the right deployment in the beginning, right? So What most people do is they spend a lot of time basically just training the model, right? And then basically training it locally. But what we did very, very fast, we set up everything on the cloud already, which was also pretty cheap for us, right? Because you don't need to spend 20,000, 30,000 euro on an NVIDIA GPU cards, but you can use the GPU instances on AWS, which is very, very, very cheap in the beginning. Obviously, the setup is very complex these days. So these days, it's much more simpler now. This is something that we did like 4 to 5 years ago, which is already it was already state of the art for the teams at the time. So, as I said in my talk, it took us 12 weeks, right? So it's all the title. So what did we do in the first iteration, and what did we do in the second iteration? So the first iteration, it took us 8 weeks. Where we actually trained the model on a existing data set which was open source. So it's called AVER dataset. So this is a data set that was created by a photo community. I think it was around 200,000 images, where people basically ranked these images from 1 to 10. So 10 is a very nice image, and 1 is a very bad image, right, or a low quality image. And then in the second iteration, what we did basically was to fine-tune this model from the first iteration on an in-house labeled data. And I want to show you why the second iteration is key, and why it was really, really necessary that we had to release, basically this model very, very fast in order to understand better how we can actually improve the model. So this is actually the results of the first model. Just forget about all these metrics like linear correlation coefficients or Earth mover distance, but just focus on the histogram, because it's really, really easy to understand. As I said, basically we trained this model on the ranking between 1 and 10. So where 10 is basically this is a very nice image, and 1 is actually not a good image, right? Subjectively. What we did basically is, as I said, we took this on this public data set, we trained this model with the Earth mover distance as a loss function, and this is what we get. So afterwards, we predicted it on unseen data, and as you can see, that the predicted means that we got was not really, really good, right? So we got it so our predicted means was between 3 and 6, and the standard deviation was also not very good. So ideally, you would like to have a distribution that overlaps with the expected means and the predicted means, that they're together. But I will show you why this is the case. So we also train it and then also predict it on real images of our model, so of our real listings on Diallo. So as you can see here, this is the listing of one of Diallo's hotel properties, and as you can see, this is not a nice first picture, right? So I think it's just a table in the kitchen, but the colors are not really good, and also it's not a very nice view. So what our model already predicted was the order. So the order was actually quite nice already. So the first image was actually quite a nice image, and then you also got a score of 5.266, and the worst image got like a 4.55 if you can read. I think the order is fine, right? So do you think the order is fine? Yes? No? If you look at this subjectively, yeah, it's actually a nice order. The only issue is that the predicted score is really, really low, right? So the first image got only a 5.266, and the worst image got only a 4.55. This is quite problematic, because as I told you, usually machine learning is part of a product, part of a software stack, right? So if software developers would come now and say, hey, okay, this is the model that you got, but your score is that low. How can we make a rule out of this, right? Because on top of this, there's usually like a business rule. So for example, hey, please only show images that are 7 point right, or 8 point something. Right now, if you would have this low spread, this is a big problem. And it is clear because if we train this data set on a public data set where actually the scores are only between 3 and 7, right? So usually you would never get an image, this is an 8 or 9, and therefore if you would train it only on this model, you only get this. This is another issue, so because based on this public data set, so the first image is also not very nice, but also the first images by the model is not very nice. So from that, what you can see is actually in this photo community, a lot of people ranked bathrooms very high, right? So you can actually see that people love bathrooms compared to basically bedrooms, right? And actually, that kind of also makes sense because if you go to Japan, basically people love to look into bathroom first before into bedrooms, right? But we actually wanted to train a model which was more for the European customer, right? And the European customer have a different subjectivity, and they also would like to look into different things first. All right, so what we did was really, hey, let's use what we have as a pre-trained model. Let's use this open source data set that we collected, and then really, put it out, right? Put it out to our user, gain basically user feedback, right? And then understand what is actually the problem. And what we understood is, okay, the model that we basically release is really not good enough, right? It doesn't give the user experience that we really needed, and we actually need more domain-specific data. What we learned over this time was when we released it is because in the beginning we use a VGG 16 model, which has a lot of basically parameters, right? It's quite heavy in terms of computation. But the problem, as I told you, Diallo has 300 million images. So basically, if you would just use a VGG 16 model, it would take us 6 months basically to predict all images, right? And that's actually pretty too long. So that's why we also decided to use a more lightweight model after we actually released our first model. Okay, so what did we do then? So we decided then, hey, let's sit together, build a labeling application. It took us 1 day to do that, and then basically collect data, from different teams within the company. And trust me, this was one of the first labeling jobs within the company, and people hated it. So basically, we had 3 people sitting, kind of 5 to 6 hours, and basically just labeling data. So they had to look in images and then tell you, okay, this is a 5, this is a 6, this is a 7. But this is the key, right? So labeling is a key to basically successful machine learning projects. As you can see, just forget the metrics again. If you just look at the distribution, the predicted means and expected means looks really, really good now. So once we basically started to label our own data, we retrained the model with the pre-trained model that we already did, and we are able to cover basically the distribution. Yeah, looking at the example again. So this was an earlier example that I showed you. The order is still the same, but now the ranking is also pretty well. So the first image would get a 7.6, and the last image would get a 4.3. So this is really, really important that you not only look into the score isolated, but think, hey, this is really important for software as well, right? Because on top of this, you usually have business rules that is really necessary, and you need to know these requirements as well from this perspective. This example that I already showed earlier, which was the bathroom, now also the order is pretty nice. So I think this first image really shines out like compared to the bathroom that was shown before. And when the first time we saw that, actually we were quite amazed, right? That we got this order right, and that basically like a machine learning model would be able to do that automatically. So this is pretty nice. All right, once we did that, we also deployed it in production. So this is actually an image of the production cluster that we had at this time. Anybody still knows OpenShift? Yeah, one person. It's actually kind of dead, but it's was an early time of Kubernetes. I mean, everyone, there's so many of this Kubernetes flavor right now. But what we did is we spin up an hotel image as a aesthetic classifier, and then basically scale it up to 100 pods. We use at the time we still use Flask. But I think today I would use Fast API. So if you're interested later to Sebastian's talk, he's giving an introduction to Fast API. Yeah, obviously, once we got into production, we could not sample all these images, you know, like what we did before, and show all the orders and then check, hey, if everything is correct. What we did then basically is, okay, let's predict all 300 millions. And then let's plot like the score for 1 million, right? So you will not look all of the images. And our biggest worry and biggest concern was that basically the classifier would only, you know, give a rating of 5 or 6. So, but from 1 million images that we basically sampled, we could see that it gets the distribution between 2 to 9, right? And also you have images between 4 to 7 and so on. So this was also pretty nice that we saw that. What we also did is we basically sampled low scores, mid scores, and high scores. So as you can see, this is like some samples from the mid score, from the low score. So as you can see, all these images in terms of quality, in terms of aesthetic, were not really nice. So this was quite good. The middle score was also pretty okay. So basically, as you can see, all these images are not top quality. Weirdly, food was also still in the mid score. Obviously, we didn't have actually food in the new labeling, what we did. But as you can see, the model will not get everything right. But what worked really well from the sample was actually the high score, right? But this is what Diallo was really interested into. So the model gets the high score pretty well. Yeah, that is pretty amazing. Yeah, so end of the story. So basically, it took us 12 weeks from basically getting the problems, you know, understanding the data, training a model, to basically productionizing it, right? Only in 12 weeks. And then, you know, a couple of weeks later, basically it was also in production. So basically, when you would go to hotel.diallo.de now, the gallery and also the first listing is actually powered with the machine learning model that my team built. All right, so I will come to the end of my talk. So what did we learn today? So I basically explained that how you can use basically product concepts, right, in machine learning teams to minimize risk. What you should really like take as a summary or take as a basic conclusion at home is machine learning. If you just do it isolated, or if you work in a machine learning team and it is isolated from anywhere outside of the organization, it's going to be doomed, right? So machine learning usually it's part of a product. You need to really work together with a product. People, you know, with software developers, also with designers, to make it work, right? If you look at the machine learning product lifecycle that I explained, you know, it's really like similar to product life cycles with build, measure, learn. So you can use similar concept what product people already did over the last 10 years, right? And really apply it on machine learning projects. Stay lean in AI. So as I said, I mean, all these things sound so simple, but they are so complicated in reality, right? Don't reinvent the wheel when you start a project. So there's so many existing libraries these days. There's so many pre-trained models. Start there first, right? Don't really try to code your own kind of deep learning model layer, right? Use what you have already, and then basically add up, you know, your own flavor from this. Deploy as fast as possible. So I think one of the things that machine learning teams are still not good at is DevOps, right? And data teams in general. So these days, I think DevOps is really core, right? And you really need to make it right. And then at the end, obviously, not quite sure about Sweden, but in Germany, we are quite dinosaurs in some companies. So the cloud is still something abstract for many companies. But if it's here, but you should already use the cloud whenever you have the opportunity. All right, thanks for having me, and yeah, enjoy the conference.